Hello and welcome to Hollier's Help. Today, Lauren asks to please explain limiting reagents. So what is a limiting reagent? It's the one that limits the amount of product that's produced. So none of it will be left when the reaction is complete. Whereas an excess reactant, some remains when the reaction is complete. It's not all used up. So if we have a small amount of A and a small amount of B, we'll produce a small amount of C, a small amount of D, if it's a one-to-one-to-one relationship, yeah? If we have a big amount of A and a big amount of B, we'll produce a big amount of C and D. But that's not how it really happens. It's never really in stoichiometric ratio in real life. What we have is one of the reactants or reagents, doesn't matter what you call it, that's in a bigger amount than the other one. So in this reaction, you've got a lot of reactant A, a small amount of reactant B, and the small amount of reactant B is going to run out more quickly. We're going to have some reagent A left over, but the small amount of reactant B is going to be running out, and that's going to limit the amount of product we've got, C and D. If you look at it again, if you've got B as the bigger amount, it will actually be left over, and A with a smaller amount will be the limiting reagent. A will limit the amount of C and D that's produced. So in this one, we've got A is the reagent in excess, B is the limiting reagent, and that will govern how much of C and D are produced. In the second one, A is the limiting reagent. It's going to limit how much of C and D are produced, the products, and B is the reagent in excess. There'll be some of that left over. Okay, let's say we put some magnesium metal into hydrochloric acid and we want to know the volume of gas that's being produced. First thing we're going to be doing is writing out our equation, making sure it's balanced, make sure it's got the states of matter, and of course we know that that gas that's being produced is hydrogen because it's an acid plus metal reaction. So we now have to say which one of these reactants is going to be the limiting reagent. Which one is going to limit the amount of gas that's being produced? So we're going to look at both of the reactants because in this case we're given information about both of them. It's not saying that one is in excess, it's not telling us already, we've got to calculate it. So let's have a look at the hydrochloric acid. We're going to use C is equal to 1 over V. We're going to rearrange it so that the moles is the subject. We're going to substitute in and we get 0.015 moles of HCl. That's how much has been added to that reaction vessel. Now we're going to have a look at the magnesium. We know that we've got 2 grams, and once we do the calculations, we figure out that we've got 0.0823 moles of magnesium. That's been added to that hydrochloric acid. Now which one of those is going to be left over? Is there going to be some magnesium that hasn't reacted, it's left over? Or will the magnesium be all used up? Maybe the magnesium is the limiting reagent, and that would mean there would be still some HCl remaining in the reaction vessel. So we're going to look at the hydrochloric acid and say, if the hydrochloric acid is all used up, what it needs is 0.015 moles of HCl divided by 2, because we've got a 2-to-1 relationship between HCl and magnesium. So we would need 0.0075 moles of magnesium, and we've got heaps more than that. And that of course means that HCl is the limiting reagent. That means HCl is going to limit how much hydrogen is produced. So we can use the stoichiometry again to work out how many moles of the hydrogen there is, and we get 0.0075 moles. Now, I was silly and I forgot to put the temperature and pressure in the question, so I'll just do that now. And that makes it easy for us to do the calculation because we can use this lovely N is equal to V over Vm. Vm, of course, is the molar volume. And we know that the molar volume of any gas at 25 degrees C and 100 kilopascals is 24.79 litres. Substitute that in, calculate it, we get 0.186 litres. Now I've got the question of significant figures. We're not going to use one significant figure because the magnesium metal was not used to determine the final volume of hydrogen, so we're going to use the information that we're given about hydrochloric acid, and that means we've got two significant figures. So the volume of gas that was produced was 0.19 litres to two significant figures. So Hollier's top tips for limiting reagents. Always calculate moles of all reactants. The only time you would do that is if the question tells you already that one of them is in excess. Otherwise, you've got to do the calculations for both of them. Be careful to use the stoichiometry correctly. There are too many students who multiply when they should be dividing or divide when they should be multiplying. You've really got to think about it. And always, always, always show you're working. It makes it easier for you to check your mistakes when you're reviewing your question. Include the units and think about sig figs. I hope this has helped you understand limiting reagents.